All right, today we're going to tackle one of the most, and I mean most, fundamental concepts in all of AI. We're talking about the intelligent agent. It's kind of the secret ingredient that powers everything from the Roomba buzzing around your floor to the most sophisticated self-driving cars out there.
So let's just jump right in with a question. What could you, a little cleaning robot, and a self-driving car possibly have in common? I know, it sounds like the setup to a weird joke, right? But the answer? Well, the answer is everything we're talking about today.
So here's what we've got on tap. We're going to cover what an agent actually is, how it sees and acts, what makes one rational, and then we'll wrap up with this really cool design tool called the PEAS framework.
Okay, first things first, let's break this down. What exactly is an agent? You can think of it as the fundamental, the absolute most basic building block of any AI.
The definition is actually super simple, almost elegant. An agent is really just anything that does two things. First, it perceives its environment. It senses what's going on around it. And second, it acts on that environment. That's it. Seriously. This simple little loop, perceive and act, is the foundation for pretty much all the mind-blowing AI you see out there.
And what's so cool about this is how universal it is. I mean, look at this. For us, a human agent, our sensors are our eyes, our ears, all our senses. And our actuators, our hands, our legs, our voice. For a robot, it's pretty obvious, right? Cameras and infrared are the sensors, and the motors and wheels are the actuators. But here's where it gets interesting. Even a piece of software fits this. Think about your spell checker. Its sensor is you typing on the keyboard. Its actuator is how it displays the correction on the screen. It's the exact same idea, just different parts.
So now that we have the basics, let's look at how this all fits together, because it isn't just a one-and-done deal. It's a constant, never-ending loop.
Okay, so here's a key detail. An agent doesn't just react to what's happening this very second. Its decision is based on what we call a percept sequence, and that's just a fancy way of saying it's the complete history of everything it has ever seen. Think about it. It's just like us, right? Our memories and past experiences totally shape what we do now. It's the same idea for an agent.
All right, to really get this, let's look at a super simple example. Let's follow the adventures of a little vacuum cleaner agent. Its world is tiny and its mission is simple: find dirt.
So, picture this. Our little robot is in, say, square A. Its sensor kicks in and perceives one thing: dirty. That's the input. That's the percept. So what happens next? Well, inside its programming, it has something called an agent function. You can just think of it as its brain or its rulebook. It sees the input, A, dirty, and it knows exactly what to do.
And based on that rule, the choice is obvious. The action is clean. Boom. One cycle of perceive and act is done. And now, it starts all over again, sensing the world to see what to do next.
Okay, that's great. Our little vacuum knows to clean when it sees dirt. But what makes a good agent? I mean, what if it just cleaned the same spotless square over and over again? It's still perceiving and acting, but it's not being very smart about it, is it? This leads us to the huge idea of rationality. How do we tell the difference between a smart agent and a dumb one?
It all comes down to this really simple but powerful idea. A rational agent is one that does the right thing. Simple enough, right? But defining the right thing is where it gets interesting.
And that's where something called a performance measure is so important. This is basically how we keep score. And here's the key takeaway. We judge an agent on its results, not how it got there. For our vacuum cleaner, a great performance measure might be how much dirt it sucks up in an hour. We don't really care how it decides to move, as long as the floor ends up clean.
So for an action to be rational, it has to take 4 things into account. First, that performance measure we just talked about. What's the goal? Second, any prior knowledge it has about its world. Third, what actions is it even capable of doing? And finally, that percept sequence, everything it's seen up to this point. And this is so important. Rationality doesn't mean being perfect or knowing the future. It just means making the best possible move given what you know right now.
So let's boil it all down. A rational agent is just one that, at any given moment, picks the action it expects will maximize its performance score. That's it. It's always trying to get the highest score possible.
Okay, this is all great in theory, but how do people actually build these things in the real world? Well, there's a fantastic blueprint they use to lay everything out before they even start.
It's called the PEAS framework. And yeah, it's just as simple as it sounds. It stands for Performance Measure, Environment, actuators, and sensors. This is like the checklist every AI designer runs through to make sure they've clearly defined the problem before they get their hands dirty with code.
Let's make this real with an automated taxi. Just look at its performance measure. It's not just get there fast. It's this incredible balancing act between being safe, fast, legal, and making the ride comfortable, all while trying to turn a profit. And its environment? Total chaos. Roads, other cars, people, customers, it's wild.
Okay, now let's flip to a totally different world. A software agent, a medical diagnosis system. Here, the performance goal is literally a healthy patient, which is huge, but it also has to worry about costs and lawsuits. And get this, its entire connection to the world, its actuators and sensors, are just a screen and a keyboard. It's amazing how the same PEAS framework works for such different challenges.
All right, how about something much more controlled? A part-picking robot in a factory. Here, the performance measure is crystal clear. What percentage of parts did you put in the right bin? Super straightforward. The environment is just a conveyor belt, totally predictable. And its actuators and sensors, an arm, a hand, a camera, are perfectly designed for one job. A beautiful example of a focused, effective agent.
And one last one, just to show you how broad this goes. An interactive English tutor. Its performance goal? Maximize a student's test score. But think about its environment. It's a person, a student, with all their quirks and ways of learning. And yet again, its entire universe is just a screen and a keyboard. It just goes to show you this PEAS framework can be applied to almost anything.
So when you really get down to it, it doesn't matter if it's a dumb little vacuum cleaner or a super smart AI tutor. The core principles are exactly the same. They all perceive, they all act, and they are all built to rationally chase a goal. It's the same DNA in all of them.
And that's pretty much a wrap, but I want to leave you with this one last thing to chew on. Imagine you're designing an agent to manage your schedule. What would its PEAS be? What's the real performance measure? Is it just getting everything done, or is it maximizing your happiness? What's its environment, and how does it sense and act? Something to think about, for sure.